Welcome back, students. This is the video for practice set 1. Let me zoom in a little bit. And I will be doing this, and I strongly recommend these practice set questions. Like I said before, you guys do it with pencil and paper. I'll do it here in Excel. And I'll post this Excel sheet for you guys, so you guys have the solution. Um, Again, I strongly recommend you guys go over these problems with pencil and paper because this would build your theoretical understanding of coding, especially if you're new to this. If you already know coding or you're comfortable with R, then you can pretty much eyeball this stuff and get the answer, and that's fine. For everybody else, work it out. Work it out. Take the time and work it out. It builds those memory muscles, so you get a better understanding of what you're doing, right? And it takes a couple times. I mean, you'll do it once, and you'll be like, "What did I do?" And it takes a couple times. It's the whole process of learning. So for some of you guys, it'll catch on fast. Some of you guys take a little bit longer, but I mean, once you understand it, you understand it. When people say they are not good at coding or not good at mathematics, it's a false statement. There's no such thing as being good or bad at it. It's just some people just need to take a little more work to understand it. But once you understand it, it's like a binary variable. Once you get it, you get it. All right. So for us, let's start with number one. Number one, right here. Let me zoom in a little bit more to make sure everybody can see this. All right, so number one, what is TOT? All right, so we have a vector x that is 1, 5, 6, 3, 2, right? And then I have total, that's going to be, vector mathematics in play, which is end up going to be, I'm going to rewrite this with the vector inside it. So this is basically going to be 10 times, let me copy this, cheat a little bit here. 10 times this vector minus 2 plus the same vector, parentheses, close. Excellent. All right. So this is vector mathematics in play, guys. Right? When we talked about this before in the previous in lab 1. A number times a vector or a number plus a vector, what does it give you? It gives you a vector. R simply takes that number and applies that mathematical calculation to each element in the data container. All right, so let's do the first part first. Let's minimize this. So the first part will become TOT equals 10 times each value. So the first one's going to be 10 times 1 is 10, 10 times 5 is 50, 10 times 6 is 60, 10 times 3 is 30, 10 times 2 is 20. All right, excellent. And I can go ahead and apply in the parentheses right here. Same thing to the other vector. 2 plus 1 is 3. 2 plus 5 is 7. 2 plus 6 is 8. 2 plus 3 is 5. And 2 plus 2 is 4. All right. So now I have two vectors, right? And now a vector minus a vector, guys, is going to be a vector. So now it's going to be basically element-wise math. 10 minus 3 becomes, this happens position by position. 10 minus 3 becomes 7. 50 minus 7 becomes 43. 60 minus 8 becomes 52. 30 minus 5 becomes 25. And 20 minus 4 becomes 16. And so the final answer for TOT is that 743, for math right, 743, 52, 25, and 16. Excellent. And that is number one. Easy. Number two, what is x? This is straight from our slide. So x is going to be basically, the first value is 55. The second value is a vector from 1 to 10 in steps of 2. Starting from 1, increases to 3, to 5, to 7, to 9. And it stops there because the next number would be 11, but we have to stop at 10, including 10. So we have to stop right there. And again, for my foundation students, remember in R, that second number is inclusive, unlike Python, which I have no idea why they would do that. So it is what it is. And the second vector there is 2, 4, 5, which we can just simply put 2, 4, 5. And that's basically what x is. All right. Number 3, what is A? Okay, excellent. So A starts off with the same answer from number 2. So A, I'm just going to cheat a little bit, copy this, and rename this to be A. Oh, let me save this up so I can post this for you guys. Practice set 1, answer. All right. All right, so what's A of 2? A of 2 is going to be 3. You see what we're doing here? We're overriding the second value of A to be 3. So let me copy this. And the second value has now become 3. And now we're saying overwrite the 8th value to be 6. Now we're overwriting the 8th value to be 6. And that's basically 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 6, 7, 8. So number 4, the 4 over here is going to be overwritten to be 6. All right, and so my final answer is this right here. That's my final answer right there. That's what A is going to end up being. Number 4. What is T? We have a for loop here. Let us start off with line 1. B is a vector. 1, 2, 3, 4, 5. T is going to be single value vector 0. And then we're going to iterate I, the iterator I, through B. So right now we know we're going to have 5 loops, guys. We're going to have 5 loops. That in a little bit. So loop 1. I is going to take on the value of 1. And we are going, the only line of code is line 5, T equals T plus B. And that's relatively straightforward. Or is it? Okay. So let's do the right side first. T plus B. What is T plus B? T plus B ends up being T equals T, which is 0, plus B, which is what? What is B? Oh, yes. B is the vector 1, 2, 3, 4, 5, right up there in line 16. Therefore, T will end up being this. What is a number plus a vector, guys? It's a vector. So T ends up being 0 plus 1, 1, 0 plus 2, and so on. So T after loop 1 becomes a vector. T has now been overwritten to be 1, 2, 3, 4, 5. I will come up here and I will paste that there, and that is T. Does everybody see that? Okay. Now we can move on to loop 2. Loop 2, I now equals what? I now equals second value in B, which is 2. And now, again, T equals T plus B. All right, T equals T plus B, which comes out to what? T now equals T. What is T? T is the vector up in line 17 is telling us it's a vector 1, 2, 3, 4, 5. And that is plus what? It's plus B. And what is B? B is the vector 1, 2, 3, 4, 5. We have vector mathematics going on here, guys. All right. So T is going to be what? T is just a summation of those positions. So it's 1 plus 1, which is 2. 2 plus 2, 4. 3 plus 3, 6. 4 plus 4, 8. 5 plus 5, 10. So that's what T ends up being, guys. This is exactly what T ends up being. And so now I'm going to take this after loop 2 and overwrite this. So now this is what t is after loop 2. All right. Loop 3. Right, loop 3. I now equals 3. I equals 3. And again, it's t equals 2 plus 3, t plus b. So it's t equals t, which is t equals t right now, up in line 17, that is t, plus b. What is b? Still 1, 2, 3, 4, 5. All right, so what does t equal now, guys? T now equals 2 plus 1 is 3, 4 plus 2 is 6, 6 plus 3 is 9, 8 plus 4 is 12, 10 plus 5 is 15. So now for loop 3, this is what t becomes. Now we do loop 4, and I equals 4. All right, I equals 4. So what does t equal now? T will now equal t equals what t is plus b. And what is b? It's still 1, 2, 3, 4, 5. We're never updating. Here, let me scroll over now. All right, so what does t end up equaling now, guys? T ends up equaling 3 plus 1 is 4, 6 plus 2 is 8, 9 plus 3 is 12, 12 plus 4 is 16, 15 plus 5 is 20. All right, 4, 8, 12, 16, 20. And finally, we are on loop 5. And I now equals 5. Okay? T equals, t is now going to equal what t was from the last loop, plus 1, 2, 3, 4, 5. All right. So t now equals 3 plus 1 is 4, 6 plus 2 is 8, 9 plus 3 is 12, 12 plus 4 is 16, 15, 5 plus 5 is, oh, sorry, I didn't overwrite. I apologize, a little typo. I knew I was doing something wrong here. I didn't overwrite my t here. After loop 4, that is a t. Sorry. Let's run this back again. So t now equals the t from after loop 4 plus 1, 2, 3, 4, 5. I knew there was something wrong there. B, which is 1, 2, 3, 4, 5. So t now finally equals 4 plus 1 is 5. 8 plus 2 is 10. 12 plus 3 is 15. 16 plus 4 is 20. 20 plus 5 is 25. And we are good to go. And finally, so what is t? After everything's said and done, this is t. Simple for loop, slight little trickery involved in the sense that you're adding up vectors now. Here, but number 5. Number 5, what is B? B is another for loop, so let's work through it. Now here you're going to see something slightly different, guys. Here you see b equals c parenthesis parenthesis. Now we've been using the c function to create vectors, but this is the first time we're using the c function. There's no numbers or anything in it. So what ends up happening? B is created. It'll just be that B will just look like something like this in R. It will be completely empty, right? If you write capital N row on B, it would be 0 at this point. Or length on B, it would be 0 because there's no elements in it. But B does exist. B does exist. It's just a data container that's completely empty. And yes, you can do that. You can do that. All right? So that's what B is right there. A is going to be a vector from 1 to 5. 1, 2, 3, 4, 5. From here, we have an iterator x that's going to iterate through A. Fantastic. We know we're going to have 5 loops here, guys. Okay, we're going to have 5 loops again. So loop 1, x will equal 1. Now we go to line 6. If a of 1 is less, we're going to test, is a of 1 less than 3, right? Ask the question, is a of 1 less than 3? Well, what is a of 1? A of 1 is 1. Is 1 less than 3? It is. So then I go straight to line 8, and I totally disregard lines 10 to 13, right? So line 8 will be b of 1. It simplifies to b of 1 equals a of 1 plus 3. Okay, so again, we know a of 1 is 1. So b of 1 is going to equal 4. So I come up here, and now there's a value in b, and the first value is now 4. Excellent. All right. Now we jump to loop 2. In loop 2, x will equal 2. And again, we ask, is a of 2 less than 3? All right, what is a of 2? A of 2 is 2. Is 2 less than 3? It is. So I go, again, I do line 8. Here I will cheat, copy this. Change to b of 2, a of 2. So again, the right side is, what is a of 2? A of 2 is 2. What is 2 plus 3? 2 plus 3 is 5. So b of 2 will equal 5. So the second value of b is now 5. All right, excellent. Then we jump into loop 3. X is now going to equal 3. We ask the question, is a of 3 less than 3? What is a of 3, ladies and gentlemen? It is 3. Is 3 less than 3? Tis not. It is false. Because it is false, we will skip line 8 altogether, and we will jump down to the else and execute line 12. So now we're going to execute the line that is going to be b of 3 equals a of 3 minus 3. All right? What is a of 3? Again, a of 3 is 3. 3 minus 3 is 0. So this simplifies into b of 3 equaling 0. So the third value right here becomes 0. Loop 4, x now equals 4. Is a of 4 less than 3? It is not, because a of 4 is 4, so that will be false. So then it's going to be this value again. B of 4, a of 4. And so b of 4 will simplify, b of 4 will simplify into 4 minus 3, which will give me the answer -1. So the fourth value of b has become -1. And finally, loop 5, x now equals 5. Is a of 5 less than 3? It is not. So it's going to be line 12 again. So this comes out to basically b of 5 is going to equal a of 5, which is 5. 5 minus 3 is, oh, I apologize, I made a typo. 5 minus 3 is 2. So here, by the way, I'm sorry, here I see it's a typo. 4 minus 3 is not negative 1. I gotta wake up. 4 minus 3 is 1. So here, let me go here. Let me fix that for you guys. This is 1, and this is 2. All right, so finally, we are done. And our answer, at the end, what is B? B is 45012. All right, 45012. Okay, sorry for that little typo right here, guys. 4 minus 3 is 1, not negative 1. So I made that fix right there. All right, moving on to number 6, which is the same as 5. So we are good there. We are good there. Let's write down 5, 6. Let's just jump down to number 7. And what is number 7? What is E? Ah, okay. So A is 2, B is 4, C is 3, and P is 1 colon 4. A vector. What is E? First of all, let me ask you guys, what's going to happen here? E is going to be forced into becoming a vector. Why? Because P is a vector, right? A vector times a number, or plus a number, or whatever, what have you, will create a vector. So because there's a vector involved in the calculation, in the math, the resultant will be a vector as well. This is like in this is exactly like our semi-barbaric way in lab 1 solving the solution, where we took R and made it into a vector and just placed it straight into our compound return formula, and we got a vector of results back. Same concept here. This is what's going on. So what I'm going to do is I'm going to rewrite line 5E with all the numbers involved, including the vector. So number 7 becomes this. E equals P, which is 1, 2, 3, 4. Actually, let me copy this part because I have to repeat it. All right. 1, 2, 3, 4. That is P times A. What is A? A is 2. Plus P times B. Oh, I apologize. I skipped a part. So times A to the power of 2. A to the power of 2. So this is going to be this vector times 2 to the power of 2. Now P, I don't know why this is bold over some. There we go. So this will be, the second part is of the polynomial is P times B. So this is really straightforward. P is that vector, B is 4. Excellent. And the last part will be P plus P times C minus 2. What is C? C is 3 minus 2. Excellent. So when we put in all the variables, we get this equation, which is fairly simple to solve. What I'm going to do is I'm going to minimize some more. So this basically becomes 2 to the power of 2 just becomes multiplied by 4, which is like our second part over there. Right, and this becomes right here. 3 minus 2 is just 1. So we can just get rid of that. Done. Now we will solve for E. So E equals 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. Plus 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. Excellent. Plus 1, 2, 3, 4. Nothing needs to be done there. That was easy. All right. Now we have a vector plus a vector plus a vector. All right. Easy. We add them by positions again. So a vector plus a vector plus a vector. All right. Easy. It's three-way addition we're doing. So the first value is going to be 4 plus 4 plus 1, which is 9. 8 plus 8 plus 2, which is 18. 12 plus 12 plus 3, which is 27. And 16 plus 16 plus 4, which is 36. And so our answer comes out to 9, 18, 27, 36. All right? Okay. Now, at this point, some of you guys are wondering, all right, this is great. What about in situations where the dimensions aren't the same? We'll address that. We'll address that definitely in practice set 2. So we'll address that in practice set 2. You will get a warning in those situations, but you will get an answer. Unlike in NumPy, in Python, you would actually get an error and be done with it. But that's not the case here. That's not the case with R. R solves the problem, and I'll show you guys how it solves the problem. You'll get a warning, but it'll solve the problem, right? What is number 8? What is C? So, okay, this is easy. B is going to be 1 colon 10. So B ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then what is C? C is basically going to be everything in B where B is less than 5. All right, start with the first value. Is 1 less than 5? Yep. Is 2 less than 5? Yep. Is 3 less than 5? 4 less than 5? Yep. Is 5 less than 5? No. And actually, from going straight forward, all those rest of the numbers are not less than 5. So this is what C will be. All right, so this is the answer. But hypothetically, I just want to point something out. Let's say hypothetically B was a jumble of numbers like 10, 1, 3, 8, 8, 5, 2, 6. All right, this is good enough. And let's say, again, we apply that same criteria. Let's say we said, okay, wherever C is, so that C2 is basically going to be equal to B less than 5, right? So what is C2? So C2 becomes same thing, but the order matters here. You still have to go in order. Is 10 less than 5? No. Is 1 less than 5? Yeah. Is 3 less than 5? Yeah. Is 8 less than 5? No. Is 5 less than 5? No. Is 2 less than 5? Yeah. 6 less than 5? No. So your answer will be 1, 3, 2, not 1, 2, 3. The order matters. Okay? The order matters. This is the point I wanted to make here. All right, number 9. What is C? Oh, we're almost done. What is C for number 9? Oh, okay, here we're just applying 2 constraints. Okay. So here we didn't talk about this yet. We haven't talked about this yet, and I just threw it upon you. All right. So first things first, this is B. No problem there. Secondly, we see there's a logical constraint. B is greater than 5. Okay, no problem there. But now we have this extra thing going on. In those brackets, we don't have one condition, we have 2. And they're separated by this ampersand. They're separated by this ampersand right here. What is going on? What's going on here is that we can have more than one logic. That's not a problem. But those logics must be joined by either an ampersand, which stands for and, or a single pipe, this is what a single pipe would be right here. That's a single pipe. And that stands for OR. And OR. And OR. This single pipe you might not be familiar with because it's a button that you probably press like 3 times in your life on your computer. All right, you're finally using it. So what is the and OR? So basically, in this case situation, this and right here is basically saying, hey, this condition must be true, and this condition must be true. Both conditions must be true to get a true. If just one of those conditions is not true, the whole thing's false. And obviously, if both are false, the whole thing's false. So that's what and is saying. That is opposite, well, kind of opposite of what the single pipe is, which means stands for OR. If this right here, instead of an and percent, was a single pipe for OR, then what that would be saying is, hey, is B greater than 5? If this were true or that were true, just one of them has to be true for the whole thing to be true. That's what the pipe does. That's what the OR does. Obviously, if both are true, then it's true. But if just one of them are true, it's true. Whereas an and, if it's just one of them are false, the whole thing's false, right? So that's the logic behind it. So in this situation, we have a situation where both conditions must be true because it's an and. So C is going to be each value, right? We have to test each condition. Is 1 greater than 5? And is it less than or equal to 8? False. First of all, I didn't even have to look at the second condition because the first condition failed. 1 is not greater than 5. Is 2 greater than 5? No, that's false. I don't have to look at the second condition because it's an and join. Is 3 greater than 5? Nope. Don't have to look at the second condition. Is 4 greater than 5? Don't have to look at the second. Is 5 greater than 5? Nope. Is 6 greater than 5? Yes. Finally, we have a true, which now leads me to check the second condition. Is 6 less than or equal to 8 as well? Yes. Both conditions are true. 6 passes. 7. Is 7 greater than 5? Yes, that is true. And is it less than or equal to 8? Why, yes, it is. It passes. Is 8 greater than 5? Yep. Is it less than or equal to 8? Yes, it is equal to 8. It passes. Is 9 greater than 5? Absolutely. But is it less than or equal to 8? It is not. 9 does not make the pass. Is 10 greater than 5? Yes, it is. But is it less than or equal to 8? It is not. 10 doesn't pass. C ends up being 6, 7, 8. That is the solution there. Oops. All right, so that's the answer. And that's how we arrive at it. And again, the same logic applies before the example I gave before. If the array was all jumbled up, the order in which the values make the cut is the order of the way they're stored in the array. All right. Number 10. Here we have like a mathematical question. I mean, logical question here. Financial question. Slightly bigger. All right, here we go. All right, you invested $100 in investment B for 2 years and $100 in investment B for 1 year. Your rate of return for both years was exactly the same. If at the end of the 2 years the money grew to $250.25, what was your compound return? Okay, so in this situation, I would have to basically just try out different scenarios. Well, first of all, I would use Uniroot to do this. I'll use Uniroot to do this. So let me show you how we do this in Uniroot. Let's see if my R is here. Here's my R. Let me open up. Right. So I have $100. I invested $100 in investment B for 2 years, $100 in investment B for 1 year. My rate of return for both were exactly the same at the end of 2 years. It was my value was $215.25. What was my compound return? I'm going to use Uniroot to do this. So I'll call this function P. What is the problem? Number 11, number 10, or problem 10. All right, equals function And it has to equal what? 215.25. Right, and then I will return t. All right, so here's my function. Now I can simply just use uniroot. Now I know that 100 plus 100 is 200, so I invested $200 total in this investment, and 200 is less than 215, so obviously my investment grew. So I know my rate of return has to be, my compound return has to be positive. So I'll start with the lower end of 0, and I'll go all the way up to 1, that represents 100%. All right, to represent 100%, go ahead and run this. And as you can see, I get my results back, 3 iterations, almost the same. Root of 0.049. Okay, this is almost a 0, and my answer, it's, first of all, the answer is 5. Okay, 0.049999. The answer we know is 5, but look at how it couldn't get us a precise answer. It got us to like 0.04999969, whatever. It's 5, and it's almost there at 0. Again, it has to do with the equations they used. All right, to get there. So the answer is basically 5%. 5%. The answer is 5%. All right, I will go ahead and copy this code in the Excel sheet so you have it. And there it is, nice and neat. All right, and that's how we get to 5%, guys. Number 11, second to last question. You invested $100 in investment A. Year 1, it grew by 10%. Year 2, it grew by negative 5%. Year 3, it grew by 7%. And year 4, it grew by 9%. What is the compound return for this investment? Ah, yes. Okay. Let's just do this. All right. Let's do this so I have more space. Number 11. All right. So I have $100. I invest in investment A. That $100 in year 1 grew by 10%. So pretty much it grew by 1 plus 0.1, which is 1.1. All right. That, whatever that is, that in year 2 grew by negative 5%. Okay. So I can just continue on with the calculation here. Times, on year 2, 1 plus negative 5. Now 1 plus negative 5% gives me actually 0.95. This all, whatever after year 2, whatever this amount is, in year 3 grew by 7%, 1.07. And whatever this ends up being after year 3, in year 4 grew by 9%. You see that? This is basically, so now before we always did our p, when we always did our our little p times 1 plus r to the power of n, when we did with that solution, p times 1 plus r to the power of n, right? That was for a rate of return that was constant, and that's why we did it at the same, we were able to raise it to the power of n. In this situation, we can't do that, guys, because our returns for each year is different, right? We have to back out what the compound return here is. In other words, basically what this is equivalent to this, how this is equivalent to that. Okay? So, and this is why we have to explicitly write out each return. So what's my compound return for this investment? So basically, this is my formula for compound return, but I need to know what this is going to equal. What's the final amount this is going to equal? This right here will give me that final amount, right? This right here will give me that final amount. So if I simply just take this, I'm just going to copy this, stick it into R. I could have done it in Excel, but whatever. R is just so much cooler. And so this gives me a value of 121.87.84. Let me copy this, stick it back in here. So this actually ends up being that, right? In my equation here, what is P? Well, P is actually 100. All right, that's why I invested. What is my R? Well, I don't, R here stands for my compound return. I don't know what my compound return is. That's what I'm trying to figure out. What is my N? My N is the years I invested it. I actually invested it 4 years. 1, 2, 3, 4, 4 years, right? And what is my final amount? Well, my final amount is 121.87.84. See, knowing this now, I can back out what my compound return was for those 4 years. That's what's going on here. I can back out what my compound return was for those 4 years. This requires some simple algebra. This just requires us to move the variables around and isolate R, and then we have our answer. All right? So let's start by the easy part. Let's slide 100 over on both sides. So this now will become, let's divide both sides by 100. So now we have this. All right, so now we have this. This is the tricky part now. How do we get rid of the exponent? All right, everybody, pop quiz. How do you simplify, or how do you reduce an exponent in an algebra equation? What do you do? What do you do? What do you do? That's right. You raise it to its inverse. All right, so it's going to be this raised to its inverse, right? And obviously, if you raise all this to its inverse, 1 over 4, you have to raise this to 1 over 4. All right, so this raised to 1 over 4, this is raised to 1 over 4. So when you raise this to 1 over 4, this just becomes 1. And 1 plus r to the power of 1 is just 1 plus r. Right? That's it. Whereas on the other side now, let me go ahead and do this. The other side now has been raised. It still maintains being raised to its inverse, right? Which is 1 over 4. That's how we switched over the exponent from one side to the other. All right, and now all we're left with is just subtracting the 1. All right, and so this R, this will be my compound return for this particular investment. And I can simply, I'm just going to copy this again. I could do it in Excel, but what the hey. And so this is my compound return. That's it. That's my compound return. It's about 5 point something percent. 5 point something percent. So what ends up happening here is these returns, right? So these returns in these 4 years, 10% year 1, -5 year 2, 7% year 3, and 9%. So basically 10, -5, 7, and 9%. These 4%, they average out into a compound return of basically 5.07% a year. That's what they average out to, 5.07% a year over year. Compounding. Remember, it's compounding. Year over year compounding. That's basically what compound return is. It's basically like a year over year average of investment. All right? So hopefully this, I like giving this problem because it helps clarify what's going on with compound return, right? That's what we did. So now this is equivalent to if you put your money in a bank account for 4 years at an interest rate of, that investment is basically the equivalent of putting your money in a bank account for 4 years for like 5.07% a year and just leaving it there for 4 years. Same result. That's basically what it comes out to, right? Same result. And that is number 11. And finally, number 12. Oh, easy. And finally, number 12 is another function question. And I'll work this out for you guys as well again, just like I did last time. Is that too big? Perfect. Fit that perfectly. All right, and let's knock this out here for the Excel sheet. Then we'll do the same way, guys. All right, so the question is basically, oh, I totally forgot the question. What is a of 2 of 6? A is 2 of 6. All right, we want to get to the question. We want to basically solve what is a 2 comma 6. All right, seems reasonable enough. Couple twists and turns there, but we can handle it. So a 2 of 6 is basically going to make two variables, x and y. X is going to equal what? 2. And y will equal 6. All right? And now we jump into the function a. So now we have to check, hey, is x times y 12? Is 12 greater than 6? Is 12 greater than 6? Yeah, it's true. Therefore, we're going to return another function. Uh-oh. Is 12, because 12 is greater than 6, 2 times 6, right here, by the way, notice what I did here. Here now, I don't have a return outside the if-else. I have a return directly within the if-else's, two different returns. That's fine. It works perfectly fine. What ends up happening is the function will just end right here. So it'll just return this, and nothing else will be looked at. And that's why it works within an if-else. So here, but we're not returning a value. We're returning this monstrosity. So is 12 greater than 6? That is true, and that ends up giving us b x plus 1. What is x plus 1, guys? Well, x is 2, so 2 plus 1 is 3. And y minus 1. Well, what is y? 6. So what's 6 minus 1? 5. So we're going to end up returning whatever b of 3 of 5 gives us. See that? So now a2 of 6 is totally linked to b3 of 5. All right. So now I go down to b3 of 5. And that has a parameter a, which is 3, and and b, the second one in b is equal 5. All right. And now we jump in this. And the if else, a plus b is 8. We have a condition. Is 8 plus b, what is a plus b? It's 8. Is 8 greater than 8? Alas, it's not. So then we do this one, the second part, which is going to be 4 times a, which ends up being 4 times a, 4 times a, which is 3, minus 2 times b, 2 times 5. This gives us what? This gives us 12 minus 10, which is going to equal 2. 12 minus 10, which equals 2. And this gets returned. So this returns 2. So b of 3 of 5 gives me the final answer equals 2. Okay? And so now when I come back here, this 12 greater than 6 gives me b of 3 to 5, which is really 2. So this actually returns 2, which means that a2 of 6 actually returns 2, which means a2 of 6 is actually 2. And that is the answer. The answer for number 12 is 2. All right, that concludes our practice set 1 video. I'll post this up with the video, and I'll see you guys on the next video. All right, have a good day, guys.